Hello, everyone. My name is Maciej. Today, I'm going to be talking about pluggable light clients that we bring on-chain. And this is part of discovery process that we've been rolling over and over again while developing and working on the project called T3rn. So a little outline on today's talk. So first of all, since the journey about the light clients and bringing them on-chain started as part of designing the open execution system that we use in T3rn to prove the inclusion of all of the events that has happened on the remote blockchains, I would like to open with the introduction to T3rn, and then arrive essentially how we're bringing the light clients to use for the protocol, but then also how we then took the next step and exposed this interface that we use internally for the protocol to use. We expanded over SDK to build the smart contracts that directly access the light clients and enable very cool next use cases like secure bridging solutions or the oracles. So in T3rn, essentially we enable the cross-chain execution. We focus in the blockchain spectrum on providing all of the tools that would be necessary to provide a full interoperable system. And the entry to the system is possible either via designing your own smart contracts using SDK that we also work on, or directly feeding the execution via one of the extrinsics that will be submitted by potentially other parachains or any caller, really. And we focus on the fail-safe aspect, so we believe this is something that is necessary for us to cover in order to provide for developers the usability that they got used already while designing the smart contracts that work on a single ledger, where whenever the call fails, for example, you run out of gas, you expect that all of the previous operation would be effectively reverted. And this is difficult for us to do in the interoperable space. And this is exactly where we fit with T3rn and our solution. So in interoperable programming, the main problem is there could be multiple race conditions when multiple state updates would come from different chains, different sources to different targets, and how to essentially control the flow of the execution. Also error handling and multiple different cryptography scheme when you want to develop a smart contract that interacts with multiple different chains. It is difficult to sort of harness all of them together and put them into some working application-based solution. So we fit into standardizing and providing the layer for programmers to use T3rn as effective interoperable solution. So to T3rn, developers deploy the smart contracts, and we host them in the palette called contract register. And the contract register essentially holds the bytecode and is able to then provide this bytecode into one of the virtual machines. For now, we have palette contracts, so WASM-based contracts, but also palette EVM, so EVM-based contracts. And while executing the smart contracts on-chain, what T3rn does, we kind of extrapolate all of the operations that could happen on different chains, and we emit an array of artifacts that we call side effects. And those side effects are then put into open market system where all of the off-chain agents that we use, we call them executors, are able to pick up the side effects, and if the deal makes sense for them, execute them on-chain on different consensus system, and then provide the proof that this execution has happened, and this proof will then, in the next step, be ensured in a fully trustless way using the light clients that indeed the inclusion of event or call or transfer or getting price, calling a swap or adding liquidity indeed has happened. And furthermore, in the next step, to provide this kind of effect for the end user that the execution has been reverted, we then provide the kind of asymmetric operation to all of the listed here examples of operations that are possible to be called directly from the smart contract, and then understood by the off-chain agents, the executors, to either commit or revert them on the target chain. Essentially, this is how we envision the aforementioned smart contracts to be written. This example here is written more or less associated with ink, written in ink, and then it compiles to WASM blob. So we provide also the additional set of libraries where we can effectively access all of the individual blockchains and spawn them all together into interoperable execution. So, for example, this Ethereum Gnosis, they already come with provided set of side effects. And we also, on the SDK end, we know exactly the number, for example, of if we want to issue the transfer, we know exactly the number of decimals, we know the encoding of the cryptography scheme on the target. Therefore, we are able to encode all of the necessary arguments that would have to be executed then by executors throughout the on-chain execution. And yeah, as mentioned, light clients has become in the center of our attention lately, where we try to expand the execution from not only the execution that would go between different parachains, but also go beyond to different remote to Polkadot consensus system. So essentially, light clients only store the headers. Having the access to all of the headers and ensuring that all of the headers match the next one, light clients also assume that after checking the finality proofs and the finality transitions, the finality proofs that are included in the headers, light clients also assume that majority of consensus that generated those proofs was honest. But this is enough for us to validate that execution indeed was included on the remote blockchain. Most of the light clients are written off-chain. This is like a general tendency that has been so far primarily, I believe, because on Ethereum, the on-chain computation was pretty much expensive. Also, on-chain storage can be expensive. So, for example, we now experiment with light clients that is collecting all of the headers from Grandpa. So, assuming we run as a parachain on Polkadot and we want to verify all of the execution that has happened on Kusama, we store the Grandpa headers from 1 day, and it's approximately 18 megabytes. 1 day of headers from Ethereum 2.0 is circa 5 megabytes from a single day. And also difficult to combine when we want to work with multiple light clients, difficult to combine the different signature schemes, different Merkle trees that particular blockchains would use. But then we took advantage of designing the solution with Substrate, where parachains are already adjusted to do some heavy computational tasks. We can utilize off-chain workers whenever the computation is too heavy to happen on-chain. Also, we can store all of the mentioned storage on-chain on collators. And also on Substrate, we are able to access relatively easy multiple different cryptography schemes. So Snorkel, Edward curves, Ethereum compatible, and ECDSA, Bitcoin-like compatible cryptography schemes. They're all available and easy for us to utilize on Substrate. This is the current status quo of our development on light clients. So we already have the Grandpa light clients that is functional and working, deployed to Rococo. We started experimenting with Binance Smart Chain and also Ethereum 2.0 light clients, and we see that this kind of need for expanding over the next light client, since we already provided a nice interface for plugging in light clients, we see that there will be a need of providing the new light clients. So we wanted to tailor a nice system that would enable us to plug in the next light clients. And those light clients we package for the use of proving the execution within the T3rn protocol. We package them within an abstraction called the portal. So the portal can verify inclusion on the source chain, having provided all of the encoded proofs and the necessary event interface to then decode to enact on the expected form of all of the exact data structure that would be provided as part of the proof. But then we took the step further into essentially having that portal already for the use of the protocol. We then started experimenting in bringing the access to light clients to also provide the access to light clients via smart contract SDK that we developed. So we can see this previous example now, where within building a smart contract and accessing operations on different chains, it also could be expanded on verifying the next state, proof, event proof, or verifying transaction, looking into each individual Merkle route. And this appears for us to be quite useful. And eventually what it means is that we can, using that sort of interface that provides you with the access to all of the headers that are already verified and checked by our system of light clients, we are able to then build out the next application layer based on those access. So enabling another bridging solution that effectively works without the bridge, since all of the light clients data is already there, becomes relatively easy. Also building out all of the oracles that, for now, there is always this need to kind of like offboard the data that Oracle will use, package it into some system, and another verification that happens off-chain on oracles, and then provide the data back on-chain. This is now, after enabling the light client interface, this is now kind of redundant, since all of this data is already there and accessible. And effectively what it means that the Oracle solution could potentially be redesigned to never get off-ramp to the off-chain, but always stays in a fully trustless manner on-chain. So all of the sort of price generation oracles, this all would be possible to build out. Yeah, I think that might be my last slide. Thank you so much for your time. And yeah, don't hesitate to follow us on all of the social media. And thank you.
Thank you so much. Does anyone have questions? Cool.
Hello. This all looks really great. I have a question. You say you have the light client protocol, so that's on your validators, on your network. So are they pulling these block headers from all the other chains?
Yeah.
So they, like when you configure the validator, you configure like the RPCs for other blockchains.
Yeah, so the collection of headers, like some off-chain, the artifacts of headers on the remote chains, we provide the kind of the interface, the standardized interface of accessing them from our T3rn parachain.
Yeah.
But then the collection of all of the headers, this must be incentivized by sort of an application layer.
Exactly.
That is also built within the system. So for now we call them rangers, because they collect the headers in the ranges. And yep, they included in turn, they included as part of the fee segregation at the very end of sharing the transaction reward.
Okay. So like they include the data as a signed transaction or?
Yeah. They submit these chunky headers, but it is also possible for us, and this is how we configured it for now, because the data is quite chunky. We configured it as payable false, so the ranges don't have to pay, and we have the additional kind of a check, like if this data has already arrived to kind of,
All right.
So, but you can definitely go over into designing the kind of the better application structure for it and the better incentive layers. But this is more like an application layer, how to incentivize the off-chain agents for you to provide the good data from different chains.
Yeah, exactly. Okay, cool. Thank you.